Now let's see the sum and difference property of derivative. So far we have seen how to find the derivative of a constant as well as a power. Now let us apply a difference and sum rule. That is, if, for example, y is equal to f of x, which is u as a function of x, one function, plus or minus v as a function of x, then f derivative at x is the derivative of the first function plus or minus the derivative of the second function. That is the theorem. Now, in order to elaborate this one, let us use an example. For example, the first one, find dy dx of, let's see, 2x squared over 9 minus 5 7x squared. Do you see there are two functions here? The first function is 2x squared over 9. The second one is 5 over 7x squared. And, it is the difference, which is a minus 1. Now, according to the rule, you have to take the derivative of the first one, 2x squared over 9, and the derivative of the second one, which is 5 over 7x squared, right? Then apply the power rule. That is, 2 over 9 is constant, then 2 down x 2 minus 1, then the second one is 5 over 7 x2 negative 2, then the derivative of this one is, you have to minus 5 over 7 negative 2 x negative 2 minus 1. The first one becomes 4 over 9 x. Now when you simplify, 4 over 9 minus 2 times negative 5 becomes plus 10 over 7 x2 minus 3. That is okay. Or as a positive exponent form, you can write this one 4x over 9 plus 10 over 7x cubed. So both are the answer for the derivative, but make sure this one is negative exponent, this one is a positive exponent. So this is one example of the sum or difference rule. Let's use another example. Let's see, B, find, let's see, G derivative at W if, as a function of W is given, for example, 4 over 9 W to the fourth power plus 7 root W. Now, the first thing you need to do is you have to write G as a function of W terms of a power form, so that you can find the derivative easily. Now 4 over 9 W negative 4 as a power form plus the radical 7 W 1 over 2. The second step, use the power rule. That means you have to multiply 4 multiplied by negative 4 over 9 W negative 4 minus 1, right? Plus 7 times 1 over 2 W 1 over 2 minus 1. Do you see this? So this is negative 16 over 9 W, the power is negative 5, 7 over 2, 1 over 2 minus 1 is W negative 1 over 2. So this is as a negative exponent form. That's fine. Or as a positive exponent, you can write negative 16, 9 W positive 5 W to the fifth power plus 7 over 2 W 1/2. This is also possible, positive. Or you can write the answer for this one as well, 16 9 W to the fifth plus 7 2 radical w, also another version of the answer. So 3 of them are possible. But sometimes the instruction said that please write in terms of positive exponent, negative exponent, and so on and so forth. So please follow the instruction when you write your answer. But the 3 of them are possible version of the derivative of the given function. Let's add more example. Let's see. Find h derivative at t if h of t is given by 5 over t 2 over 3, you see, 8 over t 1/4. Now, the first thing you need to do is you have to prepare the function to be in a power form so that you can do the derivative by using the power rule. So the first step, h of t is 5t minus 2 over 3 minus 8t minus 1 over 4. This is the first step. Then h derivative at t, 5 times negative 2 over 3 t minus 2 over 3 minus 1 minus 8 negative 1 over 4 t minus 1 over 4 minus 1. Now this is 5 times negative 2 is minus 10 over 3 t minus 2 over 3 minus 1 is minus 5 over 3. This one minus minus plus, and 8 over 4 is 2t minus 5 over 4, right? This is as a negative exponent form. Or this can be written as negative 10 over 3 t 5 over 3 plus 2 over t 5 over 4. This is another way of writing the answer. Let me add one more example. Let's this one is D, I think. D. Another example. Find d by the x of 1.4 over root x minus 4.7 x negative 2 the power plus 2x. You know, this is some difference, you know, different 3 terms. Now, first, setup. The setup. For example, the first one, 1.4 x negative half. The second one, okay, as it is. The third one, 2x. Remember, 1 over root x is 1 over x half. This is equal to x negative 1 over 2. That's what I did for this one. Now, take the derivative of each of them. 1.4 x negative 1 over 2, the first one, minus 4.7 d by dx of x negative 2 plus d by dx of 2x. That is the sum and difference rule. Now, the derivative of this one is 1.4 times negative 1 over 2 x negative 1 over 2 minus 1. The second one, 4.7 times negative 2 x negative 2 minus 1. The third one is just 2 because, you know, 1 minus 1 is x to the 0. So this becomes, you know, negative 1.4 over 2 x negative 3 over 2. This one is 4.7 times negative 2 is plus 9.4 x to negative 3 plus 2. So you have to simplify negative 1.4 over 2 is negative 0.7 x negative 3 over 2 plus 9.4 x to negative 3 plus 2. This is possible, or, you know, you can write this one as a positive exponent form. x3 over 2 plus 9.4 over x to the third plus 2. Or if you are asked to write in terms of root form, 0.7 over the square root of x cubed plus 9.4 over x cubed plus 2. So these are possible versions of the derivative of the given function.